YouTube channel. Now basically each episode I'm going to cover a physics topic and hopefully try and explain it in a simple and understandable way. Some episodes are just going to be fun physics facts, but most of them I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Today I'm going to talk about nuclear fission. This is the process of one heavier atom being split into two lighter atoms. Say you have one heavier atom, no offence, and it gets hit by a slow-moving neutron. As a result of this hit, it gets split into two lighter nuclei, otherwise known as daughter nuclei. So as well as one atom being split into two lighter atoms, there are also 3 neutrons produced as a result of this reaction. However, the combined mass of the two daughter products is actually slightly less than the mass of the original heavier atom. So we've lost some mass along the way. Where are you? Due to the equation energy equals mass times the speed of light squared, or E equals mc squared, we now know that this loss of mass results in a burst of energy. I'll give you an example. Take a uranium-235 atom and collide it with a slow-moving neutron. This neutron is then absorbed by the uranium nucleus, resulting in a uranium-236 atom. This neutron-heavy uranium-236 atom is now unstable and is vibrating heavily. The repulsive force between the protons in the nucleus is now so strong that it begins to separate it and splits the atom into two separate nuclei, creating a large amount of energy. So in my example, the uranium-236 splits into two daughter atoms, producing krypton, barium, and don't forget about the 3 neutrons. So there you have it, that's basically all there is to nuclear fission. Woohoo! To continue with my uranium example, in a nuclear reactor, the 3 neutrons produced and emitted by the first reaction can then go on to collide with other uranium-235 atoms, causing more fission reactions. This is known as a chain reaction because the products from the first reaction can then be used to stimulate the next reaction. And so on, 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 and so on. However, before the emitted neutrons can collide with other uranium particles in the nuclear reactor, they need to be slowed down. In a fission reactor, normally either graphite or water is used to slow the neutrons down. So you have a nuclear reactor that has a core that moderates the reactions and facilitates neutrons striking more uranium and creating more energy. Let me give you a brief explanation as to how the nuclear reactors work. You have rods that contain the uranium fuel, and you insert these into the core of graphite or water, and nuclear fission occurs! Ta-da! But it needs to be controlled. Because it's a chain reaction, if it's left uncontrolled, it could create an atomic bomb. We're messing with dangerous stuff here. So now we want to extract the energy that is being created by the fission reactions within the core. We surround the core by a substance called a coolant. It's basically water or some sort of gas. So the energy created by the reactions in the core heats it up and therefore heats up the coolant that surrounds it. This now heated up coolant carries away the heat and is used to create steam to drive the turbines. The spinning of these turbines creates the energy that we harness for the grid. It's fairly simple, but this type of energy production via nuclear fission can be dangerous if not controlled properly. Anyone seen Chernobyl? Thanks for listening! If you like this video and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to do a video for you.